Hey everyone, welcome to Cooperative HVAC. Today we're going to be discussing proprietary versus open source and why a lot of private businesses or for-profit businesses in general choose proprietary designs over open ones. So enjoy. First, you have your air handler. Something seems off about it. It's not working quite the way you expect it to. And you bring a technician in, they say nothing's wrong with your system, and hey, it looks like there might be a bug in your product. That technician then needs to work with the company. They need to get a fix for it, if there ever is a fix made and put out for that product, and then eventually come back out. You might need to pay them for all this stuff if it's not covered under warranty, and you get this update if it even fixes the problem at all, however long it takes to get that update. You don't own this firmware. You don't have any right to change it. You're reliant fully on the company to do that for you. If you have an advanced system, it is collecting all of the data for how the machine is running, its efficiencies, any weird performance stuff about it. But to access it, you might have to pay for it. You might have to use their app. You might have to be a part of their program and be a technician before you can even access any of that data. And hey, isn't this your unit, installed in your home? How come you need to jump through all these hoops to get access to your data? And lastly, let's look at a case where you have a more highly efficient unit. It has a smart thermostat that's, you purchased with the unit, and it fails. Something goes wrong and it stops working. Now you need to go out and buy that particular thermostat again. And if that company doesn't make that thermostat, then you're just out of luck. Either you need to lose the efficiency that you paid all this money for, or you can replace your entire unit, which is just a terrible outcome. So these things aren't unique to HVAC. If you look at printers, you can get printer ink for 20 times the material cost of the ink itself. Obviously that's terrible, but it's the way things are. And now they're starting to charge you subscription fees. The same thing, look at cars where they're charging subscription fees for the heated seats. A lot of companies are starting to do this, and it's not the best place for the world to be going. So to start off today, let's talk about why companies decide to keep their products proprietary and what that means for you. This kind of makes sense, right? If I'm a proprietary company for profit, and I put all of this effort into research and development and hiring skilled engineers, I want a return on my investment, and I don't want my competitor to come in and take my product design. So I want a good return and good value for that money spent, right? So logically, I'm going to keep that product proprietary, not share that information, and try to squeeze as much of that out as I can in service, in aftermarket, and in all those areas. But let's consider the consequences to you, the consumer, the person who hypothetically owns this thing. I guess they now have subscription HVAC, so I won't get into that world, but hypothetically owns this HVAC system, right? So with this design being private, now if something breaks on it, you need to go back to them, get an OEM part that might be specifically fitted to that particular unit. This has been common in Apple, where they have a specific screen or battery that is aligned with that unit, and it won't even work properly. It won't have all of its features enabled if it's not an OEM part. So firstly, if something breaks on this unit, you now need to go back to the company who sold you this product and get usually an OEM replacement part, something that they can guarantee works in your system. Sometimes you don't have to do that, but companies are trying more and more to push customers into requiring those locked-in parts. Next is ecosystem lock-in. So as I kind of just mentioned, having those fancy thermostats and having remote temperature sensors that go throughout the rest of your house, those things you can tie to the unit, and now the customer has to buy that. and buy the thermostat and buy the other parts that go with your product. And they can charge as much as they want because it has to be that sensor, that thermostat that syncs with your unit. Finally, when they need to connect their product to the internet, they might need to get a dongle, they might need to pay a subscription, they might need to use your app to set everything up. And so, again, this is your product that you own with your data on it. And to access any of that, you might need to be going through entirely their servers in their cloud and pay extra money per month to even get access to any of that stuff. These are some basic examples, but in practice, you can go look up, for example, John Deere tractors and how locking all of those proprietary things down and servicing of the machines and parts, how that impacts their systems. While these decisions are, they have a purpose, they end up leading to you paying more, you getting stuck with a product that might not work at the end of the day, and something that just doesn't feel like you own it. Maybe you're paying subscription fees for something that, again, you paid a huge amount of money for when you purchased it at the start, and it just doesn't feel right. There has to be a better way, right? So what would an alternative to proprietary products be? Open source is one of the examples, probably the total opposite, and it really flips the script on this paradigm where you're sharing your schematics and your firmware and your design documents so that anyone can see them potentially. And this really changes it from designing to lock down a product to building a infrastructure that then your product can lean on to make itself better. So looking at some examples of open source, Linux is probably the most common. It's the backbone of servers, and a lot of people are switching operating systems to move towards Linux now. And it is just a foundation for a lot of technology out there, whether you know it or not. Android is an example of a Linux derivative product where if Linux didn't exist, how much harder would it have been to create Android and that mobile operating system. In the same vein, but focusing a little bit more on hardware, there's a company called Opulo that makes a Lumen P&P, and this is a pick-and-place machine. And the biggest difference there is that they're not just software. It actually has the hardware and software that they open source, as well as other tooling that they use. And they gained a huge advantage by having people find bugs and submit fixes for them, having people test out a product, even if it's not perfect, because there's different expectations when you're paying for it and it's proprietary versus open source. And someone might have had a unique bespoke issue that someone could fix and give that back to the Lumen P&P team. And now everyone gets that fixed, and that's awesome. They've been successful, and I want to try to replicate that model at Cooperative HVAC. I trust open source more than I trust proprietary, which sounds weird because you're paying all this money for it, but you don't know what you're getting, and you don't know who made fixes. Someone might not know, anything they're working on in a proprietary software, and just because you paid for it and it's proprietary doesn't make it better necessarily. As an example, the Linux Foundation has upwards of or around 71,000 individual contributors and 3,000 active organizations in contributing to that product. Tying this back to HVAC, if you're not going to have that scale, but if you can take the issues that different people are facing on their units and have the general public or technicians offer feedback based on the issues that they see in Canada versus Arizona, in West Coast versus East Coast, in install where they have a different sized home or different distribution system in the home. All of that can then feed back without needing an expert team that you've put together and spent a ton of money on, because everyone wants to make this HVAC product better. Like Linux, it compounds and will make a better product in the long run. The other aspect of this is sustainability. So the example I gave earlier with a thermostat, if your smart thermostat, your fancy $800 thermostat fails and they don't make it anymore, that's it. You might just scrap your whole system. If you're working with an open source product, people might step in in that environment and say, hey, we know the interfaces for this product and we can make an alternative for it. We can make an adapter that fixes the issue. We can even take it apart and replace the part that broke. We have the firmware so we can reload the microcontroller. All sorts of factors that you can recover from a company going out of business or not being a part not being manufactured anymore, making it way more sustainable. Finally, and this is kind of obvious, but it also leads to a greater good. So Opulo, by making Lumen P&P, they are contributing back to society the software that makes it successful. They've contributed back testing tools and documentation tools and tools for the routing when it's actually doing the placements, and that's awesome. Even if they're not successful or something happens and they go out of business, like that stuff will continue on, and they will have made like this weird small niche of technology like a little bit better, and everyone's going to benefit from that, and that's pretty damn cool. The question on everyone's lips is, why doesn't everyone do open source, right? And I gave a couple reasons earlier, but there are some negatives, and these can be fought against or improved. But let me go through some of those. There's two common situations that can occur. You can either have design by committee, where you have a ton of people helping with a project, but then it can kind of become a mess because everyone wants a different thing. Everyone gives in PRs that ask for different features, and all those features and parts and components have to fit together. And at the end of the day, do they fit together well? Is it well maintained? Especially in the world of AI now, pull requests are very easy to do, and are they of good quality because they're done? Not necessarily. And having so many people can really drive a project astray if you don't have a strong leader in place. Another thing, and this especially impacts HVAC or what cooperative HVAC is trying to do, is churn. So at a big company, you can release an update and then not touch the product for a long time. And that's in fact probably what happens too often. In open source, you might have a lot of people giving contributions, and they're not doing it on a company's budget cycle to a company's whims, and this can kind of get back to the distributed leadership as well. But with all those changes, how do you manage that? How do you manage the quality of it with hardware and HVAC? How do you manage certification of that stuff? That's definitely going to be something to work through and understand how you're going to tackle it. Another thing to watch out for are free riders. And with open source, people can take your work and not pass it forward, not pay it forward. And you can get by that to a certain extent with licensing. So you can use a license that's a strong copyleft license, like GPL or AGPL. And what that strong copyleft means is that when someone uses that code or that design, they are also required to make their stuff open using the similar or same license. And it's kind of infectious, so to speak. And people who use proprietary code and don't want their code to be exposed or shared obviously don't like that and might avoid using the open source stuff, but you kind of force them to make that decision. Do they want to use the open source stuff and share and give back to the community, or do they care more about having their proprietary closed source code and designs and things like that? So that's how you can fight back against that. Finally, and again, I've mentioned this a little bit throughout this conversation, but when these things break, who do you go back to? With open source, I did mention that there's the advantage that the community can help fix bugs and solve issues, but in the same vein, something breaks and doesn't work, you might not have anyone to go back to. Or if the original person who developed this product stepped back from their open source work, they might not be supporting it anymore. The community might not have taken off. It might not be very big. It's harder because it's not a for-profit company that has obligations to maintain this stuff. And so how do you ensure that it does have legs and keeps growing and can stay maintainable for a long time into the future? That's definitely something that needs to be worked on, and you need to build good foundations to ensure that you're not caught off guard in open source with sustaining these projects. Lastly, this is probably obvious, but open source by its nature oftentimes is done out of the goods of people's hearts, or hey, I need a tool and I'm going to make it and put it out there for free for people to work with and use. But they might not get paid for that. They might not have funding, and you're sharing it freely. So technically, no one has to pay you. So the other big challenge is making sure you have a way to actually make money, so you can make something sustainable and give it back to the community in a way that will maintain itself long into the future. None of these things are small questions. Like, all those are pretty huge and fundamental questions about how can you run a business and design technology so it lasts and is repairable and robust. But that's partially why I'm doing this, to say, how can we do this for HVAC? Again, how do you get certifications? What does that look like? Can you do distributed manufacturing and share some of the manufacturing practices for the HVAC systems? How do you decide what changes and fixes get put into the products? And then when those changes come in, how do you recertify that stuff? What does that look like? Definitely some challenges that aren't unique to HVAC, but as with anything, there's always hurdles to get past those challenges. And I think it's gonna be exciting to try to get past them and bring you along for the ride as I do. So number one, running a business is not easy. And I have respect for anyone who starts a business, makes products, especially in today where so many people make intangible products that you can't touch in the physical world and aren't physical things. Someone who does that, kudos, hats off to you. That's awesome. So I can't blame anyone who does stick with proprietary stuff and feels that that's the right direction for them, even if I think that there's going to be a better way to go in the future. Hopefully this gives you something to think about. Take some of the things I've spoken about here and just go do some research on your own. Think about how would this apply in HVAC, and come chat with me. Let's talk about it. Let's work through it, and I'll bring you along for the ride as I'm trying to solve some of these problems myself. Okay, and as usual, I have a Zulip chat, so look in the description. You can hop on there and discuss with me in real time. I can pose some questions about some of the things I'm working on more directly. The scripts for these videos are posted online at cooperativehvac.com, so you can go check those out. They'll actually even be posted up there before I finish the script and post the video, so you can see future videos as they're being worked on. And if you have any questions or comments, I'd really appreciate you to put those down below. And if you enjoyed the video, please like and subscribe. Thank you.